right, friends. Well, we are moving past polygons and we are starting into circles. So today, this is chapter 10. We're skipping chapter 9. Chapter 10, and sorry, this is section 10.1. We're going to talk about vocab today and then also area and circumference. So should be a lot of kind of review for you. Hopefully, I hope, yeah. So let's just kind of talk about some of these parts of a circle to start off with. Okay, so we're going to look at this box on the right hand side. Okay, the center of a circle. The center of a circle is exactly what it sounds like. It's a point in the middle of the circle. Okay, now the definition of the radius is the distance from the center to one side. Okay. Okay, a chord is a segment connecting 2 points on the circle. And a diameter is a special kind of chord. It is a segment, actually, it is a chord that goes through the center of the circle. All right, now we're looking at some words that maybe you haven't seen before. Secant, okay? Secant is a line that crosses a circle 2 places, okay? And a tangent, okay, this is different than the trig function tangent. A tangent is a line that touches, I'm having some definite issues with spelling today, that touches the circle 1 time. So, what do you think the point of tangency is? The point of tangency is the point where the tangent line touches the circle. Okay. Then we start talking about arcs, okay? And there are actually 3 different kinds of arcs. There are minor arcs, major arcs, and semicircles, okay? A minor arc is just what it sounds like, okay? So an arc is just a portion of a circle, okay? A portion of a circle. And a minor arc is an arc that is less than 180 degrees. So what is a major arc? A major arc is an arc that is greater than 180 degrees. And a semicircle is an arc that equals 180 degrees. Okay. All right, 2 more things. Angles. We know about angles, okay? So a central angle is an angle whose vertex is the center of a circle, okay? And an inscribed angle is an angle whose vertex is on the circle. Okay, so that's just some vocab. All right, let's take a look at what that might look like on our picture here. So we have these 2 circles, all right, and we're going to figure out what these, we're going to classify each of the parts that are in these problems, okay? So LQ, okay, so here's the segment LQ, okay? Do you see how LQ, this is actually a segment, but it only touches the circle in one place, okay? So that segment that touches in one place is called a tangent, okay? Let's see, number 2 is WY. WY. Do you see how this is a segment whose endpoints are on the circle? Okay, so that means this is a chord. Okay, let's see. Angle NQR. 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 So this is an angle, and we can see that the vertex of the angle is on the circle. So an angle whose vertex is on the circle is called an inscribed angle. All right. On number 4, we have point X. Point X is the center of that circle. Okay. All right, we're going to talk more about arcs later, but here's how we label them. So this is a new notation. Remember how in geometry we're not very creative, okay? We're not creative. So whatever the notation is just a little picture of what it is. So this arc right here tells us this is talking about an arc. Okay, now if you use 3 letters are either a major arc or a semicircle. And just like angles, they kind of tell you the order you're supposed to go in. Okay, so I'm looking over here at R, and then I'm going to W, and I'm going all the way around to U. So R, W, U. Okay, remember if there are 360 degrees in a circle, okay, RWU is more than halfway around the circle. So if it's more than halfway around the circle, that is called a major arc. All right, let's look at line ST. Line ST, okay. Line ST touches both circles at one point. That point is R. So a line that touches a circle one time is called a tangent. Okay, I'm going to have to move up and down probably, so try to do it slowly not to bother your eyes. Okay, so PN. So PN, this is a segment that goes from the center to the circle. So that segment is called a radius. Angle UXY. Okay, so let's look. Angle UXY. See how the vertex is at the center X? So that is called a central angle. All right, now here's another arc, arc MQ. We're only using 2 letters here, so that's going to be a clue for us. Okay, MQ, when I look at MQ up here, MQ, I see that that is less than half of the circle. So that is going to be a minor arc. And we use 2 letters to talk about a minor arc, and then 3 letters to use a major arc or a semicircle. So this is a minor arc. Okay. Segment QN. So QN goes through the center of this circle. So QN is a diameter. If it goes through the center, then it is a diameter. Okay. Point R. Point R. Here's point R. Okay. Point R is where that line touches those circles. Okay. So that is called, point R is called a point of tangency, because that is where the tangent line touches the circle. Okay. Then we have line UY. So line UY is right here. See how this line crosses 2 places? That is called a secant line. secant. Okay. Number 13, QRN. Okay. So this is an arc, starts at Q, goes through R, finishes at N. Do you see how the end points of this arc are QN, which is a diameter? Okay, so that means that this is half the circle. It is a semicircle. So that arc is a semicircle. All right, number 14, MPQ. MPQ is an angle whose center is at the, whose vertex is at the center. So it is called a central angle. Okay. Segment QR touches the circle in two places, so it is called a chord. Okay, angle UYR. UYR. So this angle has a vertex. Y is on the circle. So if the vertex is on the circle, that is called an inscribed angle. All right, number 17, arc WY. I'm going to assume that's a minor arc. I'm just going to check it to be sure because there's only two letters. So WY you can see is less than half of a circle. So that is a minor arc. LN, okay, LN starts out here, crosses two places, touches the circle in two places. So a segment or a line that crosses in two places is called a secant. Okay. UX, segment UX. Okay, that goes from the center to the side of the circle, so it is called a radius. And our last one, RUY. RUY. Okay, RY is a diameter, so RUY, arc RUY is going to be a semicircle because it goes halfway around the circle. Okay, so that's just a little bit of vocab for you. You'll have some practice on that on your problem set. All right, let's get into some math, a little bit of math here, less vocab and more formulas. Okay, now listen, I know that you know area and circumference, so this should be okay for you today. Okay, if I was teaching 7th grade, we'd do some big investigative activity here, and I'd make you go around your house and, measure things, but this is, you've done this before, so we're not going to belabor this too much. We do need to just make sure you know how to use the formulas. The area formula is area equals pi r squared, where r is the radius, okay? And the circumference formula is circumference equals 2 pi r. Some people like to use pi d here. I'm probably going to stick to r just because that way circumference and area have the same kind of requirements for figuring them out, but we'll look at those in a little bit different ways we could do that. Okay, so number 1. So notice here, and be sure, because it's like this on your problem set too, you are supposed to be read the directions carefully. This says find the area for circles 1 through 4 and the circumference for circles 5 through 8. Okay, so the first 4, we're going to find just the area, and then we'll look at circumference. Okay, so for area, that formula is pi r squared. in this picture, you can see that the radius is 12. Now, you need to have a calculator with a pi key on it, okay? Any of the calculators that I have recommended all year have a pi key on it. Don't just use 3.14. Use the pi key, all right? Now, if you have a graphing calculator, the graphing calculator letter pi, if you see the divide symbol and you see right above the divide symbol, you have this caret key. You see in blue, it has pi. So when I put this in my calculator, I'm going to put second pi 12 squared. Okay, so that's the same as 144 pi, which is approximately, because we know that pi goes on forever, 452.4. Now, you need to include units on this, okay? So remember when we're doing area, we're really figuring out how many squares fit inside of it. That's what area means, how many squares fit inside. So when we do our units, this is units squared. Okay, so you might make a note up here under your area formula that this is in units squared. And I'm going to actually write that definition inside. How many squares fit inside? All right, number 2. This time I'm not given the radius, I'm given the diameter. But I know that the radius is half of the diameter. So when I put my radius in, I'm going to use 9. So if I want the exact answer, I'm going to get 81 pi. But if I want the approximation, I'm going to do it in my calculator. Second pi 9 squared. And that's 254.5. And again, inches squared. Okay, I'm not a huge person that takes off all the time for units, but in this case, I will take off for units because it's important that you know the difference between area and circumference. Number 3, area equals pi r squared. It's a good idea to just write it down every time. I'm putting in 2.8 squared. And so when I do that in my calculator, second pi 2.8 squared, that's 24.6, and that's feet squared. Now, I want you to do number 4 on your own. Use number 2 as an example. Okay, number 5 through 8, it says to use circumference. So let's remind ourselves, what does circumference mean? Circumference is the distance around, okay? So it's like the perimeter of a circle. So it's the distance around, and so that's like we use a special word for circles. We call it circumference, but it's really just the perimeter of the circle. Okay, so in this case, since we're talking about a distance, we're just using regular units. We're not squaring them because we're just using the regular units. It's not how many squares fit inside, it's how many units around. Okay, so here we're going to use circumference equals 2 pi r. Circumference in this case, the radius is 7. So when I do that in my calculator, 2 pi times 7, that's going to be 14 pi, which is approximately 43.98 millimeters. Just millimeters, not millimeters squared. Number 6, circumference equals 2 pi r. So in this picture, I see the radius is 15.6. So when I do that in my calculator, 15.6, I get 98.02, and that's in centimeters. Okay. Now number 7, I'm given the diameter and I have a choice. I can either use pi d or 2 pi r. I'm going to be consistent. It's up to you what you want to use, but I'm going to be consistent. So first I'm going to find the radius by doing 58 divided by 2. That's 29. Okay, so then I'm in 2 pi times 29. So that would be 58 pi, which is approximately 182.2, and that's in yards. Okay. Try number 8 on your own. Okay, use number 7 as an example. All right, again, be sure you're reading the directions on all of these problems, okay? This one says use area and circumference formulas to find radius or diameter, okay? So it just depends what it's given us in the problem. It says find the diameter of a circle with circumference of 65.97, okay? So I'm going to start off, and I'm going to always write my formulas. We're kind of working backwards here. So we're going to figure out what information we have and where it can go. In this case, we have the circumference. So in place of C, I'm going to write 65.97 equals 2 pi r. Okay, I want to get r by itself. I'm getting the variable by itself. So I'm going to divide. How do I get the variable by itself? I divide by the coefficients. In this case, the coefficient is 2 pi. Now, when you divide this on your calculator, you must put the 2 pi in parentheses, okay? So like, I'm going to write down exactly what I'm putting in my calculator. 65.97 divide by parentheses 2 pi parentheses, okay? So you can do that with me here. Divide by parentheses 2 pi. Okay, and I get r is equal to 10.499. Now I want to find the diameter. So the diameter is 2r, so I'm going to take times 2 here. And I'm going to round that up. This is r equals 21, and that would be in meters. Okay. Number 10, find the radius of a circle with a circumference 21.99 feet. Okay, so again, circumference, when it says circumference, I'm going to go ahead and right away write down the circumference formula. Then I'm going to plug in what I know. 21.99 equals 2 pi r. So to get the radius, I'm going to divide by 2 pi. Don't forget to put that 2 pi in parentheses in your calculator. So when you do that in your calculator, you get an r of 3.5, and that's in feet. Okay. We're going to do number 11 together, and the reason it's just a teensy bit different. Find the radius of a circle with a circumference of 35 pi yards. Okay, so here, the pi, they left the pi in it. That's okay. It's going to actually be easier for us. Circumference equals 2 pi r. In place of circumference, I'm going to put my 35 pi. And I'm going to solve the same way I did before. I'm going to divide both sides by 2 pi. Okay, now when I do that, these divide out on the right-hand side. Do you notice also how the pi's divide out on the left? So you don't even have to put pi in your calculator this time. You're just going to do 35 divided by 2, which is 17.5. And that's in yards. All right, now number 12, we're kind of moving on to area. Okay, so find the radius of a circle with an area of 380.13 square inches. So first thing I'm going to do is write the formula I'm going to use. Okay, in place of A. Okay, now This solving is a two-step process. We can't just do it in one step like we did before. Okay, remember when we plug things in, we use, please excuse my dear Aunt Sally. So when we plug stuff in, we do, right? But when we are solving like we are here, we are undoing. So we are going in the opposite direction. So the first thing we need to undo is the multiplication. Okay, so I'm going to divide by pi first. So, and that's in my calculator, 380.13 divided by pi. I got 121 equals r squared. Okay, and then I will take the square root of both sides, and that will give me 11 inches. Okay. This time on number 13, I'm finding the diameter, but look at my formula. My formula uses radius, so I have to find the radius first. So it says area is 615.75, so I'm going to put that in place of the A. Okay. So first I'm going to divide by pi. That's my first step. 615.75 divided by pi. And I get 196 equals r squared. And when I take the square root, I get 14 centimeters is going to be my radius. But I wasn't asking for radius. I was asking for diameter. So now I need to multiply that by 2. So the diameter is 28 centimeters. Number 14. Diameter with a circle of an area 90.25 pi. So start with your area formula. Plug in what you know. Here, when I divide by pi, okay, my pi's divide out. So now I have 90.25 equals r squared, and I'll take the square root of both sides. Okay, so that my radius is 9.5, but it doesn't ask for radius, it asks for diameter. So I'm going to multiply by 2. My diameter is 19 meters. All right. All right, these last few are kind of two-steppers, so look carefully at the directions, okay? Find the area of a circle with a circumference of 26 pi feet. Okay, so I'm going to have to find area, but I'm only given circumference. So the first thing I have to do, I'm going to write my circumference formula. I'm going to put in my 26 pi here in place of circumference. 2 pi r. And then I'm going to divide both sides by 2 pi just like I did on those other problems. My pi's divide out here. And then I'm going to get a radius of 13. But I'm not done because it asked me to find area. So now I'm going to take my area formula and I'm going to put in that 13 that I just found, which is 169 pi. And that is approximately 530.9. And this is area now. That's how many squares fit inside. So feet squared. Okay, look at number 16. Number 16, we're looking for circumference and we're given the area. So we'll start with our area formula this time. We'll plug in the 289 pi equals pi r squared. Let's divide by pi first. Those are going to divide out. And the square root of 289 is 17. So now I'm ready to use my circumference formula. Circumference equals 2 pi r. Circumference equals 2 times pi times 17, which is 34 pi, which is approximately, 106.81 millimeters. And since this is circumference, We just need regular millimeters, not millimeters squared. Okay, number 17. We've got our area of 113.1. Area equals pi r squared. So I'm going to put the 113.1. I'm going to divide by pi first. Okay, 113.1 divided by pi is 36. So then when you take the square root, you see that r is equal to 6. Circumference equals 2 pi r. Circumference equals 2 pi times 6, which is 12 pi, which is approximately, I'll put that in my calculator, 37.7 inches. Number 18, find the area of a circle with a circumference of 30. Okay, so here I'm starting with circumference. That's 131.95 equals 2 pi r. So I'm going to divide by 2 pi. Don't forget, when you're finding the radius from circumference, you have to put that 2 pi in parentheses. Okay, and you get 21. Radius of 21. So now take that, pi r squared, and put that in your calculator. It's 441 pi, which is approximately 1,385.44. And this is area, so it's squared meters. All right, number 19 is very similar to number 18. So go ahead and try that on your own. And the last one, find circumference when I'm given this area. So 1,809 and 56 hundredths is equal to pi r squared. Divide by pi. 576 equals r squared. Take the square root. So r equals 24. So now circumference equals 2 pi r. .48 pi, which is approximately 150.8, and that's centimeters, okay, because circumference is just distance around. All right, good job, guys.